Hello students. So we have been discussing about the questions from the NCERT exercise in exemplar. So let us continue the second part of this. Read below this statement carefully and state with reason and example if it is true or false. We have to tell true and false. A particle in one dimensional motion. So we need to consider only one dimensional motion of the particle. Okay, first, with zero speed at an instant may have non-zero acceleration at that instant. So you need to consider only straight line. Okay, right, with zero speed. So speed is zero here, speed is zero, so the particle is moving in a straight line, and right now at this instant its speed is zero, right? With zero speed at an instant may have non-zero acceleration at that instant. Non-zero acceleration, so velocity and accelerations are independent. Accelerations may be non-zero, acceleration is not equal to zero, but velocity is zero. Is it true or false? Can it happen in one dimensional motion or not? That is the question. So it is possible. Yes, why not? For example, there is a one very good example practically. When we throw any object, right, its velocity becomes zero at the topmost point, but it has acceleration. Always it is under acceleration, right? Its acceleration is constant, which is downward acceleration due to gravity, 9.8 meter per second square downward. So acceleration can exist always, but velocity can become zero at one instant, right? So this means this can be true, right? May have non-zero acceleration at that instant, right? This is true. Then next, with zero speed may have non-zero velocity. So they are saying that speed is zero, speed at that instant is zero, may have non-zero velocity. So you should note that velocity, the magnitude of instantaneous velocity, that is what is speed. Suppose this is velocity, right? You take the magnitude of that. This is what is speed. Speed. So at any instant, if a body is moving, at any instant, its velocity is zero, instantaneous velocity is zero, so speed is also going to be zero, right? So with zero speed may have non-zero velocity. This is not correct. This is false, right? Then next, with constant speed must have zero acceleration. Constant speed, it has constant speed, and it has zero acceleration. It can have zero, it must have, they are saying must have. Okay, must have zero acceleration. So its speed is there is a constant speed, and it must have zero acceleration. Think about it. Can it happen in some cases? Straight line, we have to think about a straight line. So let us say a body is going with a constant speed, v equal to constant, right? Like this way it is going, must have zero acceleration. Its acceleration is zero. So if the direction changes, then only it will have some acceleration, because let us say the body has constant speed and direction is also constant. That means its velocity itself is going to be constant, right? So the body will be moving in this path, right? So they are saying that it has zero acceleration. So if the body is going in the same direction, right, and same speed, then velocity is constant, then it must have zero acceleration, right, in a straight line. And what about it changes its direction, but let us say speed is not changing, direction it has changed. Is it possible such case? So if I assume that same direction is there, same direction, same direction, and speed is, this is speed v is constant, means speed is constant. Okay, same direction, same speed, same direction, same speed. So if the body is going same direction, same speed, means velocity is constant, so acceleration must be zero. Definitely acceleration must be zero. But now, is it possible that it can change direction? For example, suppose if a body is going like this way and it is hitting some wall or some surface, right? After that it is bouncing back with the same speed, it is bouncing back. but velocity has changed, so definitely there has a force acted on this body and there must be some acceleration. So now the question is this possible or not? Must have zero acceleration. Here it must have zero acceleration, but in this case acceleration will not be zero, correct, because it has changed. But definitely the ball may take some time. If the ball, so this question has to be interpreted properly. There may be possibilities of both answer, but we have to decide like which answers can be possible. So it is going with a constant speed, must have zero acceleration. Think about it. In this case, definitely acceleration must be zero, right? True. But what about this case? This case, if it, we have to only consider straight line motion, that also we have to keep in mind, right? Otherwise, answer may vary. Only straight line we have to think. So if it is coming and bouncing back, so is it possible in such case? Can we consider or not consider? So, but velocity can become zero here when it is in contact. This is what we have to analyze here. The force that will act on it is an impulsive force. Even though force is impulsive, some time is there, although the time is very, very small. So during that time, the body may come instantaneously at rest. And if the body comes at rest, then speed will not remain constant. This is an important point to note, because what happens, let us say during the contact, which may happen for a very, very small time, during the contact, the ball does not move. So its speed will become zero, right? In this case, if the speed becomes zero, then speed cannot remain constant, right? Speed cannot remain constant. So if you consider this means condition, right, in this condition, if you take that acceleration can happen, yes, acceleration can happen due to collision because there will be impulsive force, right? But in that case speed will change then, so we cannot consider this case itself with a speed constant. So this case you cannot apply, right? This case you cannot apply. So you have to take only that case, and if you are taking that case, then this is a true statement. Yes, true. Clear? But let us consider now, it's a good question. Suppose if they say that let us take 2 dimension or 3 dimension, is it possible? It has a constant speed, must have zero acceleration. So if you take circular motion, now think of uniform circular motion. In uniform circular motion, body has a constant, right? Body has a constant speed, but it has a centripetal acceleration, right? The body is going in a circle, let us say. Its speed is constant, v is equal to constant, but it has got an acceleration which is called centripetal acceleration. There must be acceleration, right, in that case. So in that case it will become false in 2 dimension if you are studying, right? Then next, with positive value of acceleration must be speeding up. Positive value of acceleration means what? Suppose I am considering a straight line, okay? Let's try to understand that. I am taking a straight line. This is an important, thing that we have to understand, the concept of acceleration and retardation. What is that concept? Suppose, for example, a body is going in this direction, okay? Velocity is this direction and acceleration is also in this direction. That means they have same sign. So acceleration is positive, and velocity is also positive. Or you can take opposite way. Suppose the body is moving this way, velocity is this way, and acceleration is also this way. So acceleration is also negative and velocity is also negative, both. So in both the cases their speed will be increasing, right? Their speed will increase. So this case as well as this case, speed increases, speed increases. Here also speed increases. So when speed increases, we can say acceleration. So acceleration means the speed is increasing, right? But actually it is the rate of change of velocity. So the idea is that velocity will be increasing, or when we say velocity increases means what? A vector quantity increases means what? Whenever we say vector quantity increases, we are talking of the magnitude of that. That means we are saying that the speed is increasing, right? So speed is increasing. This is the case of acceleration. But what happens in retardation? Retardation means acceleration and velocity is opposite. This is acceleration and velocity will be this way. Or you can take this case, velocity is this way, acceleration is this way. So you can see here acceleration is positive and velocity is negative, and this case acceleration is negative and velocity is positive. They are opposite. So in this case speed decreases, speed will decrease, speed decreases. So this is what is called retardation. Sometimes there is a confusion, and this is the confusion which they want to highlight in NCERT, that acceleration positive, generally we say acceleration positive means acceleration, speed will be increasing. No, why? Because acceleration can be negative also and speed can increase. So it depends on sign of both acceleration and velocity. If the sign of both acceleration and velocities are same, then it is speed is going to increase. But if their signs are opposite, then it is called retardation, then speed will decrease. So when we are talking about this question, right, with positive value of acceleration must be speeding up? No, false. So the answer of this will be false. False. So I hope you are understanding this, right? These are very, very important conceptual question, which generally they are asking in Nelson region type of question, or it got applications in problem solving as well. Fine. A ball is dropped from a height of 90 meters from on a floor. At each collision with the floor, the ball loses 1/10 of its speed. Plot the speed time graph of its motion between 0 to 12 seconds. Right. So we need to plot what? We need to plot the graph of speed. Remember, this is speed. V represent speed. So first let us consider that V is velocity, and wherever velocity is negative we can take the magnitude to make speed time graph. This is the way we can think about it. Okay, so let us try that. And they are saying that collision is happening, so a body is dropped. Okay, so initial speed is 0, and this height they have given, this height h is equal to 90 meters. Correct, 90 meters. So first it is going to hit with some velocity, right? Time equal to 0 second. Plot the speed time graph of its motion between time equal to 0 second. So from where should we start? Let us say that we are starting from here where time 0, velocity is 0, right? Velocity definitely has some direction. Let us say that this direction, downward direction, we can choose as positive. Let us choose downward direction as positive. So if I am choosing downward direction, so initially it has velocity 0, 0 velocity it will be, right, time 0, and it is increasing. So just before collision it will gain some velocity. What will be that velocity? Root under 2gh. We know that, we can calculate that, right? How much it will come? Let us calculate that. So root under 2 into g. How much value of g should we use? Can we use 9.8? Let us use 9.8 because they have not given us 10. Height is 90. So from here this 10 will definitely cancel out, right? And here how much? 98 into 2, 196. 196 means 14 will come out, right? 14 will come out, and here 93 will also come out. So how much you will get? 42. 42 meter per second. So just before collision you can see this is the speed attained. So and acceleration is also in this direction. We are choosing this direction as positive, so acceleration which is equal to g is positive. So let us draw this graph, right? So we know that this is velocity time graph, and acceleration is a constant acceleration, so we need to show like uh, like a straight line, we need to show. So speed has to increase, so speed has to increase like this way, and it has attained a speed. How much speed it has attained? 42 meter per second. This speed is meter per second, this time is in second. Now after this what happens? It has some collision happens at this instant. So how much time it takes? First let us also calculate time. Time also you need to calculate. Time is root under 2h by g. H is how much? 90. H by g. G is 9.8. Okay, so from here you try to calculate, 100 will come, correct? Then here 2 will get cancelled, 49. So what will you get? Time you will get as 30 by 7. 30 by 7, 30 by 7, 4 point something will come, right? Let us approximately take 4.28 to near to 4.3 seconds. So nearly 4.3 second, when time is nearly 4.3 second, it is going to hit the ground, right? After hitting, what will happen? It is coming out with how much? 1/10. Ball loses 1/10 of its speed. So 1/10 it is losing. So remaining is how much? 9/10. Remember, 1/10 it has lost. So remaining is 9/10. 9/10 of this you need to calculate. So definitely after that, what will happen? It will be going up, right? It will be going up. So if you have chosen downward as positive, then upward should be taken as negative. Upward should be taken as negative. So if it is a velocity time graph, first let us draw velocity time graph. Okay, so it will be starting from some point here. So how much will be, first of all you calculate 9/10 of that. How much is 9/10 of that? Here I will calculate somewhere here, 9/10 of this velocity, which is 42. So calculate how much it will be. 18, 9 into 4, 36, 37. 37.8, 37.8. So it will be starting but in opposite direction, minus 37.8, right? So somewhere from here you can see, just after this point, it is going to start, right? But the acceleration direction is same, so slope will be like that only. So it will be going like this. So first of all, what will happen? It will go and somewhere velocity will become 0. Velocity will become 0. Remember, these lines will be parallel lines. These lines will be parallel lines. So somewhere velocity will be 0, and again after that some height it will attain, and then again it will be coming up back. Coming again, it will be coming back. So how much time it will take with that speed it is going? How much time it will take to come back? Think about it, and also what time it will take where the velocity will become 0. That again you need to calculate, right? So you know that formula, time is equal to root under this calculation I am doing here, time of ascent, how much? U by g. U by g. U already you know, 37.8 by g, 9.8. You need to do this calculation, correct? We need to do this calculation. Suppose almost nearly 10 if I take g, so it will be nearly 3.78, right? Or little bit less than that, correct? So 3.72 or something like that. So this will be, let us take rough time. So 3.7 I am taking, 3.78 let us say I am taking, nearly 10 I am taking that. So if it is coming here, the same time it will further also it will take here. So it will be going further, right? Like this will come. So again extra you have to add, from here to here, this is 3.78, you need to add this time, correct? We need to add this time. So add this 3.7. 3.7 let us take, for example, 3, 8, nearly 8 point something will be there. 8.7 let us say, okay? Let us say this much time. Again you can also add that double of that. So more time extra you have to add. Why? Because it is going up and then coming down in the same interval, right? So it is going up and it is coming down in the same interval. So this time also you have to add further you need to add 3.7, let us say. So how much it will be? 12.4, nearly 12.4. Okay, these calculations you can do. But what is the nature of the graph? It is like this. Again, while it is going to hit at this point, again it is going to hit, again its velocity will change. So it will be now starting with 1/10 of that. And note that whatever velocity you have calculated here, how much you have calculated this velocity? 37.8, right? So same velocity it will attain here also, 37.8. This will be 37.8. Okay, because whatever velocity it got after collision, it will again before collision, before next collision it will get the same speed, because in the air it is not losing energy. So now only thing is that this graph is going to repeat. Now I am just going to repeat this graph. So you can see I will be starting from some point less, and it will be going here like that, and then again like this, some point here like this, some point here like this. Okay, so this is a rough graph. Now what graph we need? We need speed. So wherever negative is there, let us make this positive. So I am just now going to do this graph, not this graph, actual graph. What the actual graph will look like? Actual graph will look like this negative I will remove. Okay, so this is what it is. Then this negative again I will remove, right? Then next, like this negative again I will remove. So here, then this and this. So which I am going to remove? See, I will also highlight which I am removing. This part I am removing here. This part I am removing. This part I am removing. This part I am like that. It will go, right. So this will go like this, up down, and also note very important thing, that this slope will remain constant. So this angle theta, which we are taking, this angle theta, and this angle theta will remain same. This, so tan theta will be giving us what? G, basically 9.8. I have of course made some rough calculation here, but you can do exact calculation and plot the graph like that. I hope you have got this right. Let us move next. Explain clearly with examples the distinction between magnitude of displacement, sometimes called distance, over an interval of time, and the total length of path covered by a particle over the same interval. Let us try to understand very fundamental it is. Difference we have to say, magnitude of displacement called distance sometime, okay, over an interval of time, and the total path length covered by a particle over the same interval. Suppose for example, if your body is going in a straight line from this point A to this point B, okay, body is moving like this way, body is going in this direction. So in this case, clearly note that in this case body is going in this direction, and body has not turned or change its direction of motion, right. So from A to B in this time interval, the distance is nothing but the magnitude of displacement, because displacement is AB vector or towards right side. Okay, so that magnitude is same as the distance, right, because you are comparing distance and displacement, so you cannot compare to means one vector and one scalar. So you are basically comparing the magnitude of the vector quantity. So when we say that magnitude of displacement is equal to distance, then we can compare, right. So here there is no turning, so it is the same. But suppose what happen is that body turns back. Let us say for example, body is going from position A to position B, then comes back to position C. Okay, so here note that the motion, let us try to understand, it is going from A to B and B to back to C, right. So in this case what will happen, the distance is not equal to magnitude of displacement. Why? Because displacement will be what? Displacement will be shortest, from A to B initial to final. This is what is, this length is the magnitude of displacement AC, but distance will be A to B plus B to C. That means the length AB plus BC, that is what is distance, right. That is what is distance. So distance and displacement can become equal in some cases, sometimes. That's why they have used word sometimes, because in that case direction is not changing, right. Okay, next, magnitude of average velocity over an interval of time and the average speed over the same interval. Magnitude of average velocity over interval and the average speed. Now again the same thing. How do you calculate average speed? Average speed is total distance by total time. And how do you calculate average velocity? Total displacement by total time. So here again, because these two cases are happening in the calculation of distance and displacement, same cases will happen in average speed, average velocity. So while you are calculating average speed in this case where it is not changing its direction, so in this case the magnitude of displacement is same as distance. So in this case average speed is same as magnitude of average velocity. But in this case the average speed is not same as magnitude of average velocity because distance is larger, right? So the same case, you can understand this because we are just going to divide that with time, it will become average. Okay. Next, so in both A and B that the second quantity is either greater than or equal to the first when is the equality sign true, right? So now you can understand very clearly, we can say that the distance which we are taking as distance can be greater than equal to magnitude of displacement over a interval. Remember, this concept is over a interval. When you take instantaneously, then they will be equal because a small path length or a small displacement magnitude is going to be same. So this concept is only true over a interval or a time gap. Okay, right? So this condition will be fitting. Similarly here we can say that the average speed is greater than equal to magnitude of average velocity, right? That's what it is. When is the equality sign true? Already we explained the equality will be happening when the direction of motion does not change. When the direction of motion does not change. And particularly, this is an important thing. How do you know in a graph that the direction of motion is changing? So it's a very important point. Suppose if a body is going like this way and turning back. So suppose its velocity is positive, and when it turns back its velocity will be negative. Definitely it will be zero at some point where it is changing its direction. So in the graph of velocity time graph, if you draw velocity time graph, there will be a point where velocity will be zero, right? That point, and before that and after that there will be difference of change of sign. So if velocity is, let us say, positive, then velocity will be negative when it turns back, or if velocity is negative, then after turning velocity will become positive. So in the graph you can check by substituting velocity is 0. Suppose if you have equation, you can substitute velocity is 0 and find out the time where the direction has changed, right? And then you can break the motion, right? Suppose for example at point B the direction of motion has changed, so you will be getting velocity equal to 0, you will get the value of time. So then you can do from A to B you can calculate the displacement, and B to C you can calculate the displacement, then take the magnitude of both and add. That is how total distance we will calculate, right? So try to understand. I think these things are not clear now, then I'll make a graph of it to make clear. Suppose this is velocity time graph, and let us say the body is going like this way. Let us consider it like this. And if they ask the total distance traveled between time 0 to some time, let us say here 5 seconds, let us say. Okay. So how will you calculate this? So you need to first of all find out where this is 0. Suppose they may give you some equation of this. Let us write some equation. Velocity is equal to 2t minus 10. Okay, like this some equation is there. Now if they ask what is the distance traveled and displacement traveled between 0 to 5, okay. So what you need to do is that it's first of all, if you see at time 0 second, you can clearly see it's negative velocity first, right? That means body is going towards left, and then at some point velocity becomes 0. So where velocity becomes 0, you can clearly see that how much it will be. Time will become equal to 5. Okay, maybe this graph, let us keep this as 10. Okay, so 5 here. So 0 to 10 second you have to calculate distance and displacement. Now from the graph you can see, because these angles will be same, right? This angle will be same, so whatever will be this area and this area will be same. So when you are calculating the total displacement between 0 to 10, it is going to be 0, because this positive area, negative area, they give opposite displacement and they will cancel out. So total displacement between this is going to be 0. But total distance delta L, distance is not going to be 0. We need to calculate that. How to calculate that? You can just calculate this area, multiply by 2, correct? So distance delta L can be calculated as, right, this area will be how much? So first of all, you calculate what is the initial velocity times 0, this is minus 10, right? Similarly, this will be here as 10 only, correct? So what will be any of this area, and 2 times we have to do that area. This area will be how much? Half into base, this base will be 5 into this height is 10. That's all, that's the answer. That means 50 meter, like that. Okay, clear? So this type of questions do come. Sometimes they give you equation and no, they will ask you to do that distance and displacement calculation is easy. Sometimes from the graph you can get, sometimes you can integrate, right? But calculation of distance is little critical, because you need to know where the velocity is becoming 0, and if velocity becomes 0, there it is turning, right? Okay, let us move next. Question number 14. A man walks on a straight road from his home to a market 2.5 km away with his speed is. Finding the market closed, he instantly turns and walks back home with a speed of 7.5 km per hour. What is the magnitude of average velocity, average speed? So all these questions let us try to do by graph. Now graphical concepts are very important. Let us try to solve this using graph. Okay, so which graph we can draw? What are they asking? Average velocity and all that. So man walks on a straight road from his home to a market 2.5 km away, right, with his speed. Finding the market closed, he instantly turns and walks back home with a speed of this. What is the magnitude of average velocity? First of all, they are calculating average velocity. Okay, so what is given here? The speeds are given here, right? Speeds are given, like this, speeds are given, and distance is also given, right? Okay, so can we draw velocity time graph? Let us draw velocity time graph. Velocity time graph. Velocity time graph. So he is going with a constant velocity. How much? 5 km per hour. So initially the velocity is positive, like this, 5 km per hour. Let us keep the unit as kilometer per hour. Unit is kilometer per hour and time is hour. And velocity time graph will give us what? Displacement, right? So 5 km per hour he is going, and he will be definitely reaching, at some time he will be reaching here to the market. How much far away the market is? How much far away the market is? 2.5 kilometers, right? So the area of this graph must give 2.5 kilometers. So suppose this is time t1. So this area will be 2.5 is 5 into t1. So time t1 will become 1 by 2 or 0.5 hour. Okay, so this will be 0.5 hour, correct? Now after that what happens? After that what happens? So he see that market is closed, he returns back. So while returning, its velocity should be taken negative, okay, with a speed of 7.5 kilometer. Okay, so he returns back with a 7.5 kilometers. So now 7.5 kilometer means little bit larger you need to show, but negative I will show because it is returning, right? So from here, this point onwards, he has to return. So you have to draw the graph like this. And now what will be this time? This time interval. Let us write this time is t2. So this interval first we will calculate how much this interval will take. That time, that interval delta t, let us write. That delta t time is equal to, again you can use this area under the graph. So this total 2.5 kilometer only distance area under this graph. Okay, So I'm taking just the magnitude. So this time delta t into this speed is 7.5. So from here delta t will be how much? This has become 1 by 3 times 1 by 3 r. Okay, so 1 by 3 means 0.33. Let us take 0.33. Okay, and already 0.5 was there, so 0.5 plus this interval, so how much it will become? 0.5 plus 3, so 83, right? Hour it is, like that. We can draw in minutes also and seconds also, but let us keep in hour. Okay, so this is what is happening. Now let us think about it, what they are asking questions. Now let us think. Magnitude of average velocity. So average velocity, when you calculate average velocity is what? Total displacement by total time. Average velocity. So average velocity is total displacement by total time. Total time. So total time is how much? 0.83 hour. Total time is 0.83 from the beginning. Okay, from beginning. But what about the area under this graph? You know, the area is nothing but 2.5, 2.5, but plus 2.5 minus 2.5, that has become 0, right? Plus 2.5 minus 2.5 has become 0. That's all. So average velocity, because he is coming back to the same position, right? So total displacement is 0, right? Next, average speed of the man over the interval of time from 0 to 31, 0 to 30 minutes. Okay, I think now they have given in minutes, so you can think in terms of minutes. 0 to 30 minutes. 0 to 30 minutes means what? Half an hour, na? This half an hour. 30 minutes means this only, correct? This is 30 minutes. 30 minutes. So here to here they are asking average. What they are asking? Average speed. Average speed. So what is average speed? And you can see that the speed is constant anyway, so that whenever speed is constant, that itself is average. That itself is average. So in this interval from here to here, this itself is average speed. So average speed is nothing but 5 kilometer per hour. Over. Next, what it is? Next, they are saying 0 to 40 minutes. 0 to 40 minutes. Sorry, 0 to 50 minutes. Then 0 to 40 minutes. These three are there. So 0 to 40 minutes means what? So this is already 30 minutes, right? This is 30 minutes, and this interval was 1 by 3. Let us convert this in minutes. Okay. Let us convert this in minute. How much it will be? So 1 by 3 into 60. This is 20 minutes, right? So this interval is interval of 20 minutes. 20 minutes, correct? And this interval is of 30 minutes. 30 minutes. So they are asking 40 minutes means somewhere here, right? 10 minutes extra. So in this they are asking to average speed. So first of all, average speed means total distance by total time, right? So first of all, here we know what is the distance, this area under this graph. This area we know here. Already we know this area, that is 2.5 kilometer. But now from here to here, this area, when you are going to calculate, note that you are going to calculate now this area. Of course, it is negative, so that negative displacement you have to consider as positive because you are calculating average speed. So calculate this area but take magnitude, right? We can do that. Calculate, right? So how much is this area? This area will be how much? Rectangle. So this is 7.5 kilometer per hour, and this is 10 minutes you are taking. 10 minutes. 10 minutes you have to convert into hours. So 10 divided by 60, 1 by 6, right? So that means 7.5 by 6. You can simplify also this, but I am leaving it as it is. 7.5 by 6. This area, of course negative, but now let us say the total distance will be how much, because you want average speed from 0 to 40 minutes. 0 to 40 minutes, so average speed is total distance, so already 2.5 kilometer. and this area is 7.5 by 6. So total distance is 2.5 plus 7.5 by 6, right? This distance by time you have to keep in hour. So this is 40 minutes total time, 40 minutes, divided by 40 divided by 60, so 4 by 6, 4 by 6. Now you can do this calculation, right? Definitely we can find out the average. Now between 0 to 50, if they ask 0 to 50 speed, so again when they are asking the average speed, so total distance will be how much? Total distance will be 2.5 plus 2.5. So if you are taking for interval of 0 to 50 minute, 0 to 50 minute, then average speed will be, remember this is average speed, we are calculating average speed. So total distance will be 2.5 plus 2.5, that means 5 kilometers. 5 kilometer, and time is 50 minutes. 50 minutes means what? 50 by 60, that means 5 by 6. 6 will come here, so this will become 6 kilometer per hour. This calculation is easy, right? So we can find out this is average speed at different intervals. From the graph also we can draw and we can get ideas. So note that graph you can draw velocity time graph, or we can also draw position time graph. From both the graphs it is possible to calculate. Fine. Let us move to the next question. In previous question 13 and 14, we have carefully distinguished between average speed and magnitude of average velocity. Yes, we have distinguished. No such distinction is necessary when we consider instantaneous speed and magnitude of velocity. Instantaneous speed is always equal to magnitude of again. Now the same concept we are going to repeat that. So suppose if the body goes from point here to here, and it's a very small displacement, let us write dx can be positive in this case, and if you go this way, so that small dx can be negative, because displacement is a vector quantity. But now if I am interested in the small length, remember this length or this length, if I take, I will write that length as dl only, right? This length if I write, or this length if I write, I will write dl only. So that is small length dl can be just written as the magnitude of this dx, because dx can be positive, dx can be negative, but this length of the path cannot be negative. Now if I write instantaneous velocity or speed, if I write speed, instantaneous speed, so this speed will be what will be instantaneous speed? This is dl by dt, correct? This is dl by dt, and dl is nothing but the magnitude of dx by dt. Now I can take magnitude of dx by dt, full magnitude, because time anyway is going to be positive. So this instantaneous speed is going to be the magnitude of instantaneous velocity. This is velocity, okay, because velocity can be positive, negative also. So magnitude of instantaneous velocity is equal to instantaneous speed. Remember, these are instantaneous, we are talking only instantaneous, right? So instantaneously they will be equal, they must be equal, right? Fine, let us move to the next. Look at the graphs A to D carefully and state with reasons which of these cannot possibly represent one-dimensional motion. Which of them cannot represent one-dimensional motion? That means motion in a straight line. Try to understand this graph. So, if I see this, now here, this type of graph where at a particular time, you can plot it like this, a straight line, vertically straight line. It is cutting at 2 points on this. First of all, time cannot be negative. So this side, which graph which they have shown, this itself is wrong. And also one thing, that at a given time there are two positions, it is not possible. At the same time, how a body can be present at two different positions? At least in classical mechanics, it is not possible. Maybe in quantum mechanics, it may be possible, right? Because quantum mechanics is totally a different, mind-boggling branch of physics, where things can happen, which you cannot interpret it from classical mechanics. So definitely this is not possible in classical mechanics, right? And negative side time cannot be there. So this graph is not possible. What about this? Again the same thing here also. So same time, at a particular instant of time, two values of velocity is not there. First of all, these graphs are not representing function. So you have some mathematical idea what is function and relation. So function means if you draw a vertical line, it will cut only at one point. And if this is not a function, it may be some relation, then a vertical line test will fail, right? Vertical line test, when you draw a vertical line, it should cut the graph only at one point for a function, so that it has unique values, right? But here at the same time, two different velocities not existing, not possible in classical physics, right? So this is also not possible. Then what about this? What about this? Now here, definitely for time positive we can say, but what about negative time? Is time negative? Is there any significance of negative time? It is possible. Negative time has a significance. What is that? For example, suppose I am studying, I'm the observer and I am studying a body, right? So I have started the observation right now. So time zero means, note that time zero is the time when observer starts his observation. But there is a possibility of some time before that. It is not that the body is not moving before the observer start studying that. The body might be moving also. So that is what is time negative time can be possible in some circumstances where there is some earlier motion before the observer starts observation. So negative time can be taken as possible in some cases, right? This is possible. And you will be studying that this is nothing but the wave equation. But what is it? It is speed or velocity? Oh, this is speed. Speed cannot be negative. Note here, the speed cannot be negative. So definitely this is going to be wrong. But suppose if it is velocity time graph, suppose this is velocity time graph, then it is possible, because speed cannot be negative but velocity can be positive negative. So this graph is wrong because it is a speed time graph. Speed cannot be negative, right? Okay, what about the total path length? So path length means the distance traveled by the body. So if a body is moving, its distance will keep on adding up, right? Distance cannot decrease. So again, distance decreases. That is not possible. So this graph is also not possible. We can reject this graph. So that means none of this graph is possible. None of this graph is possible. Yes. Let us move further. Figure shows the xt plot of one dimensional motion of a particle. This is position time graph, right? Is it correct to say from the graph that the particle moves in a straight line for time negative and on a parabolic path for time greater than 0 positive? If not, suggest a suitable physical context. This is a parabola. Parabola graph is like x is equal to some constant, let us say some constant is there, a, capital A, into t square. This type of graph it is, right? This type of graph it is. And here before that x is equal to this x is 0 here, right? X is 0, x itself is 0 before that. So only you can choose any other values of time. So x is constant and it is 0. That means particle is staying at its own place. So let us consider that a particle is here and this is the position 0. So the particle is staying here itself. It doesn't have any velocity. So before that, before time 0, suppose I started observing time 0. So before that it was at rest. It was completely at rest. Okay. So this is possible, right? Body is not moving, it was rest. After that it has started moving. Now what does it represent? It represents that when motion has started, let us say that at some time instant t, this particle has this position. So this is representing a straight line motion, but x is the position. How position is related with time? Then this graph is showing that it is not showing the path. This path can be what? It's a straight line path. But how x changes, how the value of x changes with time. That is what this graph is showing. The parabolic shape does not represent the path. The parabolic shape represents the relation between position and time, right? Okay, then suggest a suitable physical context for this graph. That is the context, right? So party or what kind of example in practical life, what can be example? The example can be like this. For example, so suppose there is a building and there is an object kept here right now. This object was kept here on this building. Let us say downward direction as positive, and this you can take as x is equal to 0 here, this position. So time before time 0, this was at rest anyway. Now let us say it got dropped. As soon as it got dropped, this position, let us say this position x, how does this x will change? X is ut plus half it square, so initial velocity is 0, half gt square, half gt square. This is what we can understand, right? This is parabola graph. So body is moving in a straight line downward, and the relation between x and t is non-linear graph, correct? This is what is the practical example. Okay, let us move to the next. Question number 18. A police van moving on a highway with a speed of 30 km per hour fires a bullet at a thief's car speeding away the same direction with a speed of this. If the muzzle speed of bullet is 150 meter per second, with what speed does the bullet hit the thief's car? Note, obtain that speed which is relevant for damaging the thief's car. So try to understand what it is. A police van moving on a highway with a speed of, so let us say this is police van p is the police van, okay, right, moving with a speed of, it is going with a speed of 30 kilometer per hour, okay, fires a bullet at a thief's car speeding up in the same direction with a speed of, so suppose this is a thief's car, this is thief's car, it is going with a speed of how much? 192 kilometer per hour. That is quite practical in day-to-day life, because the thieves may be having a modern vehicle which will be going very high speed, and the police vehicle may be like old which is going with very small speed. Right, okay. So what is the question? If the muzzle, so he fires a bullet from here. Bullet you can take like a point and it is being fired, okay, fired like this. Hmm. If the muzzle speed of the bullet is 150 meter, so it is 150 meter per second. If the muzzle speed of the bullet is 150 meter per second, with what speed does the bullet hit the thief's car? Note that when this policeman fires this 150 meter per second is relative to the policeman. You have to note that this is the velocity of bullet with respect to police. Okay, this is what it is given. And what we need to calculate, with what speed does the bullet hit the thief's car? So this bullet is going to hit the thief car. Okay, this bullet has to hit the thief car. So this bullet will be hitting here. So what relative velocity it will hit? So you need to calculate velocity of bullet with respect to thief. This is what they are asking. We have to understand this question properly. Now we can solve it. Okay, so I think you need to convert into meter per second, or you can convert into kilometer per hour. Anything is okay, right? Suppose I convert into kilometer per hour, that may be better, because these two are in kilometer per hour, this is meter per second. So let us convert this velocity of bullet with respect to police is 150 meter per second. So 5 by 18 we do when we have to convert from kilometer per hour to meter per second. Now here we are doing reverse. So instead of multiplying 5 by 18, you have to multiply 18 by 5, right? So this will become 30. So this become 540 kilometer per hour, right? So this relative velocity is more, correct? Relative velocity, that means bullet will definitely be able to reach there. Now let us calculate that. So velocity of bullet with respect to thief, which is velocity of bullet minus velocity of thief, correct? Velocity of bullet, but this is velocity of bullet with respect to police. We can calculate this velocity of bullet minus velocity of police. We can calculate. So velocity of bullet will be how much? They are going in same direction. So velocity of bullet will be 540 plus velocity of police. Police velocity is how much? 30. So this become 570. This become 570 kilometer per hour. So this is going to be 570, 570 minus, right? Minus, what is the velocity of this thief? 192 minus 192. So let us calculate this. How much it will become? 8, it will become 6, 16. So it will become 7, it will become 4 minus 1, 3. 378 kilometer per hour. This is the relative velocity with which bullet will be hitting that. Fine. I hope you have understood this. Sometime in the question they will not mention exclusively. You have to understand that. Okay, let us move to the next. Suggest a suitable physical situation for each of the following graphs. Each of the following graph physical situation. When is this possible? This is time, negative time. So here body was at rest previously. Body was at rest, right? And suddenly this body start moving. Suddenly it start moving with a constant velocity. You can see the slope is constant. So that means a body was at rest and it start moving with a constant velocity. Okay. And after that velocity is maximum, then after that velocity start decreasing, velocity start decreasing, and it decreases, it becomes zero. After that it goes in negative direction and then it becomes constant. So where is such kind of motion possible in day-to-day life, in practical life? You can think of. So before the observation, that means before the observer start, it was rest, and sometime back it has started moving, right? And then it increases its distance, position, and its velocity. Note that here this slope represent constant velocity. After that here velocity has changed. So definitely there must be change of velocity, means some force has happened, right? Some force has happened. So let us say if there is a body and this body is moving this way. So somebody hit that body, somebody hits that body, hits that body. So as soon as a person hits that body, what will happen? It will start going in this direction, right? So before that it was not moving, right? It was not. And again see, note that here also velocity was 0 previously and it has got velocity positive velocity. That means it has also hit here by some force. So some force has also acted here. So let us say that initially somebody has hit this ball, then it is going that side. This side somebody, other person again hit that, some force have to, then it goes like this. Now it is going in negative direction and again somebody is hitting it or somebody is catching it, because after that velocity becomes zero. So somebody is now catching it. So of course in order to catch it also, now after catching it become rest, so somebody has to apply some force in order to stop it. So this is like, assuming that gravity doesn't exist, effect of gravity if you neglect, then it is like somebody is playing, tennis. Somebody hit it, previously it was rest, ball was there, somebody hit it, then somebody other has hit it, then somebody has caught it. Okay, like this we can assume a practical situation. There may be many cases possible, right? But we can think about it. Then this case we have just seen while we are drawing this graph. So initially you can see here the velocity is positive at previous time, and then velocity is going this way. So first of all, vt graph is a constant, so this represent constant acceleration. Slope is negative, so maybe it is like gravity, a body is falling down, right? So here if you see here, initially it has some velocity, and then velocity, or you can say the speed is decreasing and it is going in that negative direction. So you can assume that a person has thrown a body, a person has from a building of some height, as a person has thrown a body with some velocity, some initial velocity, you can say. So this is like initial velocity and downward direction. You take downward as positive. So initially the downward direction is positive, it is going like that, going, right? And at one point what happens, till here you can see they have not mentioned this stuff, but here when it is going to hit it, after hitting what happened, velocity reverses. You can clearly see that Where is the velocity changing in sign? I think you need to note where the velocity changing in sign. So here, just before this point, velocity is positive. After this point, velocity is negative. Yes, velocity is negative. So that means first of all, the body is going down, and when it is hitting the ground, then only velocity changing. So at this time zero, it has hit the ground. So velocity direction has changed. But remember that this like looks like a constant line, right? That means they are not considering the force due to the collision. They are drawing this just before and just after, right? Just before zero and just after zero. Then what happens here? You can see that what is going to happen here to this. What happens here? Just after this time, the velocity completely changes, becomes in this direction. So again here also there is a change in velocity. Now what is the slope of velocity time graph? If I check slope of velocity time graph, what happens? So slope of velocity time graph, gives acceleration. So you can clearly see that till here there is no change in the slope. Till here there is no changes. So where will collision happen? There can be a confusion. Where will collision happen? Will collision happen at these points where it is just going, changing here like this? Where will collision happen? Or will the collision happen where it is becoming zero? Velocity is becoming zero. Where it will happen? We have to think about it. So which case? Are we drawing the correct case or are we drawing the wrong case? Think about it. Because see, at this point velocity is becoming zero. Definitely during collision velocity just before just after does not become zero. So we need to think more little bit. This graph we cannot take. So what we can do, we can think like this. If body is thrown like this, upward direction velocity is positive, but now it is decreasing. So when is velocity zero? When it reaches maximum height. When it reaches maximum height, that place only velocity zero. Okay, so this point time zero where velocity is zero, where velocity is zero, that is where it has reached the maximum height. Okay, then after that what happens? Again same graph, it will be coming down, right, like this. Now here the collision has happened. So wherever collision happen, velocity suddenly changes. Or you should know that there is a like slope. If you try to draw, it is like a infinite slope, because slope means what? Tan theta. If you try to draw this tan theta, tan 90 degree, that will become infinity. So at this point collision is happening, which is for a very small interval, very large amount of force. But definitely some time takes in collision, which they are not showing here. Some time definitely takes in collision, but that is a very small. So this graph exactly cannot be treated as a means a true graph. We cannot take it true. Why? Because there will be some time gap before and after, because during collision also there is some time. So instantaneously we cannot say it changes. But if you neglect the time between during collision, then you can consider this case. That means you are throwing a ball, it is going up, it is stopping, coming back, again hitting, then going like this, it is happening. And during collision some speed is getting lost. So like that some loss is happening like this, right? What about this graph? Definitely here you can see this is acceleration time graph, and acceleration is like a peak they have given, peak. So during this time some force is acting. Before that acceleration is zero. Acceleration is zero means force is zero. So there will be no force here. Here there is no force. Here also there is no force. And force is equal to mass into acceleration. So acceleration is increasing. Maximum acceleration is happening. So that means, like for example, a ball. Suppose a ball is going to hit some object, let us say wall. So when it is going to compress the wall, force increases on it, and there is a deformation happens. Suppose this is a wall, it is hitting. So this wall will be applying a force on this ball like this, and maybe the ball have some deformation, structure get deformed here, right? But that will happen for a very small time interval. That force is a variable force. You can say it is like a impulsive force, a impulsive force. But the nature of force is not constant. Force itself is variable during that small interval of time, right? Good question, very analytical and practical question. Let us move to the next. Figure gives the xt plot of a particle executing one-dimensional SHM. This is SHM graph. Give the signs of position, velocity, and acceleration variables of the particle at 0 0.3, 1.2. 0.3 means here, somewhere here, because this will be 0.5. 0.3 will be here, right? 0.3 second. 1.2, 1.2. This will be 1.5. 1.2 will be here. 1.2 will be here. Minus 1.2. Minus 1.2 will be where? This is minus 1 and minus 1.2 will be here, right? We need to give what? Signs of position, velocity. So definitely if you see at 0.3, let us write. So when you take time 0.3 second, what about the position x? X you can see is down, negative. So x is negative, right? X is negative. What about the velocity? What about the velocity? Velocity is the slope of the graph. So when you draw tangent here, that is negative slope. So velocity is also going to be negative. What about acceleration? Acceleration also they are asking. Acceleration. So you should note, very important, that acceleration is shown by the double differentiation of position, and double differentiation gives what? It gives shape of the graph, whether it is concave or convex. If it is concave, then double differentiation is positive. Convex, double differentiation is negative. So here the shape is concave, so double differentiation is positive. That means acceleration is positive. Similarly, you do for other time 1.2 second. What about position x? 1.2 means here position will be positive. What about velocity? Slope is positive. What about acceleration? So it is convex if acceleration is negative, right? What about minus 1.2? Here. So when you take minus 1.2 second, position is what? Position is downward, negative. What about velocity? Velocity slope, which is positive. What is the shape of the graph? Concave. So double differentiation positive, acceleration is positive. So I hope you got some ideas about that. These are very, very fundamental, important concept. That is why we must solve each and every question of NCERT with thorough clarity, right? I hope you are getting some idea about that. Thank you for your attention. Then we will be seeing next.